Hello again. In this video, I'm going to go over section R4, objective 5, which is about multiplying radical expressions involving multiple terms. And so let's look at example 6, part A and B first. Okay, so we want to multiply this radical by this expression which has some radicals inside the parentheses. And so the way to do that is to just distribute this to all three terms. Okay, so let's multiply these two first. So distribute to here. And I'm going to rearrange the order in which you multiply. So I'm going to multiply the 3 and the 2 together, and that gives me 6. And then I'm going to multiply the square root of 5 and the square root of 5. Okay, and now let's distribute it to the second term. And again, I'm going to rearrange the order and multiply the 3 and the 4 together, which is 12. And then the square root of 5 times the square root of 2. Okay, and then of course the last one would be 3 square root of 5 times 1, which of course is just 3 square roots of 5. Okay, and then remember, you're allowed to write this, when you multiply two radicals together like this, you're allowed to write it as 5 times 5, and then take the square root of that. So those are equivalent. And that's just this property that says the square root of a times the square root of b is the same as a times b, and then take the square root of that. Okay, and then so that's the same thing here, 12 times, and then you could say the square root of 5 times 2. And of course this right here, the square root of 25 would be 5. So you just get 6 times 5 there. This is the square root of 10. And so just to finish this off, this is 6 times 5 would be 30. So it's 30 plus 12 square roots of 10 plus 3 square roots of 5. Okay, and you can't simplify these radicals any further. Okay, so that's the answer for part A. Okay, well, what if you had something like this? Well, this is a case where you would FOIL this out. Okay, so let's do first times first. Okay, so again, I'm going to rearrange the order. I'm going to multiply the 3 and the 2 together first to give me 6, and then you'll be left with the square root of x times the square root of x. So that's your first. Now your outer looks like it's going to be a negative number. Negative, and I'm going to change the order, so I'm going to put the 7 up there with the 3, and 7 times 3 is 21. So it's negative 21, and then times the square root of x. Okay, and then the inner, 5 times 2 is 10, so you get 10 times the square root of x. And then the last, which would be negative 35. Okay, and so let's just clean this up a little bit. Now, again, you can multiply the x's together first, and then take the square root of that, using this property here. Okay, so the square root of x times the square root of x is the same as the square root of x times x. Okay, so this would be 6x, or 6 times the square root of x times the square root of x. Okay, and then we'll finish this off. We'll clean this up in a second. And then these are like terms, right? They're both square root of x terms. You have negative 21 of them here, and you're adding 10 of them here. So that's negative 11 square roots of x. And then minus 35. And of course, this last part here, x times x is x squared. And then the square root of x squared is simply x. Okay, so that's your final answer for that one. Okay, so let's just look at some more. This is example 7, part A. So again, we have to FOIL this out. And I'm going to rearrange the order. So I'm going to take the first and multiply it by the first here. And I'm going to rearrange the order and put the 4's next to each other. So 4 times 4 would be 16. And then square root of 5 times the square root of 5. Okay. And now the outer, notice it's going to be a negative. And then 4 times the square root of 5 times the square root of 6. Okay, and now the inner, 4, and then square root of 6 times the square root of 5. The order doesn't matter. You could say square root of 5 and then square root of 6. Okay, whatever order you want. Order in which you multiply doesn't matter. Okay, and then the last. Now notice you're going to get, for the last, you're going to get a negative number. A negative times a positive, so that's definitely negative. And then square root of 6 times square root of 6. Okay, and so let's just clean this up a little bit. So this is 16, and then of course you can write this as the square root of 5 times 5. And this one you can write as the square root of 5 times 6. And same thing here, you can write that as the square root of 5 times 6, or 6 times 5. Order doesn't matter, so I'm just going to keep it the same as this, 5 times 6. And then the square root of 6 times the square root of 6 is the same as the square root of 6 times 6. Okay, and then this is just 25, so you're taking the square root of 25, and the square root of 25 is 5, so you get 16 times 5 there. This is the square root of 30, so minus 4 square roots of 30. And this is plus 4 square roots of 30. And so those are going to cancel out. And then this, of course, is just the square root of 36, which is 6. Okay? And again, these middle terms cancel out, right? One of them is negative and the other is positive, so they cancel out. And then now we just need 16 times 5, which I believe is 80. And so you end up with 80 minus 6, which is 74. Okay? So you end up getting 74. That's the answer for part A. Okay, now part B. Now be careful with part B. You cannot just square the first one and add it to the second one squared. Remember, when you square something, it means multiply it by itself. So you need to write this out. So it's this multiplied by itself. And so we're going to have to FOIL this out. Okay, so let's do the first. So 3 times 3 would be 9, and then x times x is x squared. And now outer would be 3 square root of 2 times x, changing the order of multiplication, which is fine. And then this, the inner. So that's your outer. Now your inner, I'm going to change the order. The order doesn't matter. So I'm going to say 3 square root of 2 and then x. So it matches the order here. And then the last would be the square root of 2 times the square root of 2. Okay, so just to finish this off, this would be 9x squared. And then these are like terms, right? They're both x terms. And so I'm going to do this on the side just to make it clear as to what's going to happen. So when you add these two together, you can actually factor this x out. Okay, it's probably the best way of thinking about this. So I'm going to factor that x out. Okay, so it looks like that. Which, by the way, is the opposite of the distributive property. If I were to distribute this x to here and to here, you would get that. So I'm kind of going backwards with the distributive property when I factor the x out. And then you can add these numbers together. In fact, one way of doing that is to pull out the square root of 2, since it's in common. So I'm actually going to pull that out as well. So I'm factoring a square root of 2 out of each of these since it's in common. Okay, which again is the opposite of the distributive property. If I were to distribute this to both terms, right, to here, I would get this. If I distribute to here, I get this. Okay, and the reason I'm doing that is because then it becomes very clear that 3 plus 3 is 6. And so this is simply 6 times the square root of 2 times x. Now, if you're familiar with how these radicals would add up, you could just say that this term and this term are the same. They're both square root of 2 times x terms. I have 3 of them here and 3 of them here. And so that means I have a total of 6 of these square root of 2 times x terms. That's another way to think of it. Okay? Either way, you end up with 6 of these square root of 2 times x terms. Okay? And then the last piece here is square root of 2 times the square root of 2, which is the same as the square root of 2 times 2, which is the square root of 4, and the square root of 4 is just 2. Okay, so we talked about earlier how you FOIL out binomials times binomials, but we can still use that FOIL method in the cases when we have radicals. And that's really what this section is about. Okay, we can still use the FOIL method when we have something like this here. Even though this is technically not a binomial times a binomial, we can still use the FOIL method to multiply these radicals out. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.